Wishing all of you a very warm afternoon, and we start with a new chapter today. Welcome to the live coaching classes, and in today's session we are going to take up measures of dispersion. We had already completed measures of central tendency in the last few sessions, and you must have followed the classes where we discussed about mean, median, mode, and within mean we had discussed about and covered different numerical examples on arithmetic mean, that is AM, GM, geometric mean, and harmonic mean. In today's session, we are taking up methods of dispersion, which will deal with number of new concepts. So the first area which we will discuss is what is dispersion. That is the first section of our discussion today. What do we mean by dispersion? Second will be what are the important points required to find out the ideal measure of dispersion. Dispersion actually means variability of data, scatterness of the data. So we will take some time to understand the concept, and then we will move on to discuss about absolute and relative measures of dispersion. In the curriculum, in the syllabus which we have for the exam, there are four important areas. First is range, which we shall be completing today. Mean deviation, which is also going to be covered in today's session. And we will cover exercises from the exam point of view. And on 23rd, that is the next session, we shall be covering the two more measures of dispersion. That is quartile deviation, abbreviated as QD. In short, we call it QD, and SD, that is standard deviation. So there are four important measures of dispersion which is included in the curriculum, and that is range, mean deviation, quartile deviation, and standard deviation. And we will understand each of them in details, the formula, the properties, advantages, disadvantages, how to calculate, and we will solve a number of problems. So we start with what is dispersion. So what is the learning objective first? So this chapter, covers two sessions today and on 23rd. So from the study material, if we just have a look at the learning objectives, so here there are different methods of dispersion. Dispersion means the scatterness of the data. Like in case of central tendency, we looked at the tendency of different observations to move towards the central part. And you may remember, for example, the concept of median, which essentially talks about the mid value. So here in dispersion, it's about scatterness. Instead of grouping towards the center, how scattered the data are, how scattered the observations are. So that is basically what we shall try to find out. And here we have range, quartile deviation, mean deviation, and standard deviation. And we will understand the computational techniques, how to compute, how to calculate, number one. Second is, as we had done in the case of central tendency, you may recollect that we had covered a comparison between mean, median, and mode. Within the purview, within the area of mean, we had three further subdivisions: arithmetic mean, geometric mean, and harmonic mean. We did a comparison. Similarly, in this chapter, the other objective is to create and understand comparative advantage and disadvantage of these measures of dispersion, so that we can understand which measure to use in practical real life situations. Plus, please remember, in the advanced stages of CA course, especially in CA final, this concept which we are going to learn about dispersion, mean deviation, coefficient of variation, standard deviation, all these concepts will be used in financial management, in understanding risk, so that you can learn the technique of financial decision making. So this chapter on dispersion is very practical in CA course, and it is used in advanced levels of our course. So these are the learning objectives, so that we have a clarity, we have a complete understanding about why we are learning this particular technique, and that is measures of dispersion. So dispersion, the word dispersed is spreading out. So observations are spread out. That means they are scattered. So statistical dispersion, what does it mean? It means the extent to which numerical data is likely to vary in terms of value. So how scattered the distribution is and how scattered the observations are from the mean. For example, if I take a certain, you can see in this slide that certain measures of dispersion include variance, range, standard deviation, coefficient of variation, and so on. Say I'm taking a small example here and I'm drawing it on the whiteboard. Say I have a curve like this, and this is the midpoint of the curve. I have certain observations, say certain observations are there, x1, x2, x3, x4, x5, x6, different values. And again, this is situation number 1. In the second situation, I am drawing another curve and this is more flat. And here what happens is the observations, please note, are scattered x1, x2, x3, x4, x5, x6. So please note in the first curve, it is more steeper. The observations are very close to the central line. On the other hand, here in the second case, case number 2, you can see that the observations x1 is here, x2 is here. See the distance between this line. So here you can see a lot of variation. So the midpoint is here, or you can call the median is here, but you can see the observation 1 is here, 1 is here, 1 is at this point, 1 is on the extreme right hand side, then you have on the left hand side these two. So if I ask you which set of observation, set 1 or set 2, which one has more variation, which one is more spread out? So if you look at these two observations, you can easily find out that in case of observation number 1, the graph which I have drawn here, the data, that is x1, x2, x3, x4, x5, x6, they are more or less close to the midpoint. And midpoint means median, it can mean the arithmetic mean, it has different types of interpretations. So here, the observations are close to the central line. But in this case, the observations are scattered. So I can say that here, this is more dispersed. Dispersion is more in this particular graph. That means the observations are scattered. So this is basically what we call dispersion. And we will understand how, yes, set 2, absolutely. Bhumika, Abdul, Dhyanesh, very good, yes. You have rightly stated that in the second case, you have rightly stated that in the second case, actually, if you look at the observations in the second graph, you can rightly say that the second graph shows wider amount of dispersion, more dispersed data. Okay. So this is one way. I am taking another example. Okay, so let us look at two classes or two groups of students. Let's take two groups of students and we have some marks. I am writing group 1 here and I will take group 2 on the right hand side, group 2. So some group of students. Now, let me take 6 marks, 6 students and their marks. So I'm taking some marks here, 55, 60, 61, 63, 1, 2, 3, 4. Then I'll take 57 and I'll take 64. 55, 60, 61, 63, 57, 64. Then in group 2, I'm taking the marks of another 6 students. Okay, let's see the marks. 51, 48, 46, 64, 73, 82. Please see carefully. Group 1, group 2. It is the marks of 6 students. There are 6 students here and there are again 6 students here in group 1 as well as group 2. Now, if you look at the marks in group 1, 55, First student has got 55, second student 60, third 61, fourth 63, fifth is 57, and the sixth student has got 64. Now, if you look at the marks in group 2, the students who have scored these marks and they are in group 2, one has got 51, second student 48, third is 46, fourth is 64, fifth is 73, and the sixth student has got 82. So which one do you think has more variability, or which one do you think has more scatteredness? So if you look at, yes, Chandan also has given the right answer. That in the second last example, the second graph was having more scattered nature. Here also, if you see, these observations are close. You can see roughly on one hand you have 55, on the other hand you have 60. So if you quickly find out a mean, you will say that the average is somewhere around 60. And most of the observations are close to 60. Some are little more, some are little less, but they are not spread out much. They are more or less close to the central line. They are more or less close to the arithmetic mean. But in this case, if you see, some students have got 46. One student has got 46, one has got 48. Now another student has got 82. That means in the second class, in group 2, some students are very good, excellent, 82 is very high. But some students are not at all good. They are getting below 50. Similarly, in group 1, in the first example, you can see that the students are more or less uniform. They are close to each other. The marks show that the marks are clearly showing that they are close to each other. There is higher competition here because you see they are very close to each other. They are finishing quite close. But in this case, some are too good, some are too bad. That means the first group has lesser variability and the second group of students have more variability. Okay, so many of you have given Sangeeta, Bhumika, then Chatan, Gadia, Dhyanesh, Abdul, Jyoti, Priyanka, yes, Archana, great. Group 2. So this is dispersion. So you see, when we try to say, if as a teacher goes to a school and a teacher wants to find out the average condition of the students in 2 classes, definitely the average marks, mean or the median is important, but then mean shows the overall position. Which class as a whole is better? So if you look at these 2 classes as a whole, you will definitely say that this class is better, first of all, because nobody has got below 50. And yeah, you will say that, yes, nobody has got more than 70 also. Everyone has got less than 70, but they are more uniform. They are neither too good nor too bad. I hope you're understanding. But in this case, one person, you see, 2 people have got more than 70 and one of them has got more than 80, but then there are 2 people who have got below 50. That means in this case, second case, some students are very good, too good. Some students are too bad, too poor in terms of performance. That means what? The curve is more wider. They are extremes. There are extremes. Some are very good, some are very bad in terms of marks. Here, if you see, it is more uniform. They are more compact. They are more closer to each other. This concept is called dispersion. So you can see dispersion is the state of getting spread out, dispersed. Okay. So statistical dispersion means the extent to which the numerical data, like I took examples, the numerical data is varying. Here in this case, the variance is more than here. Here the variance is less. If the mean is 60, you can see most of the observations are close to 60. But here, if you look at, the observations are spread out. They are quite spread out. Let us try to see. Let us calculate now. So I'll take the calculator and I'll request you to find out the mean. Okay, mean. Let me look at the mean. First of all, let us find out the mean of the first group and we will find out the mean of the second group, arithmetic mean. And you know the formula. So you just add up 55. Let us just add it up and check. what is the mean. And then we will understand a very interesting calculation we will do, and then you will understand exactly mathematically we will prove which one has more variability. So here 55 plus you have 60, 61, 63. 60 plus 61 plus 63. Then you have another, sorry, this is the average, plus 64 and 57. Plus 64 plus 57 divided by 6. Okay. So I'll just divide it by 6. So say it is, if you just calculate it once again, let's once again do it. 55 plus 57 plus 60 plus 64 plus 61 plus 63 divided by 6. Oh, it is exactly 60. The average is coming to 60, which I had written earlier, 60. Okay, now let us find out the mean of these presentations, these numbers. So we have, let me just find out 51, number one, then 48 plus 46 plus 64 plus 73 plus 82. Okay, divided by 6. It comes to 60.67. Please note carefully. But now, if you look at the deviation, okay, both are same in terms of average performance. But again, as I said, in the first class, the teacher is finding that the average marks is 60. In the second class, the teacher is finding that the average marks is 60.67. This is hardly any difference. Both have the same average. The arithmetic mean is same. The arithmetic mean, which is a measure of central tendency, gives them identical, almost same. But still, which class is better? That is the question. As a whole. So I'm sure you can see if the average is 60, here some people are getting 46 and some people are getting 82. One person has got 82. So the variability is much more. This is the concept of deviation, and this is basically what is meant by dispersion. So if you see in these examples, once again, both have the same average. So the mean, central tendency is same. The average is same. But in this example, yeah, many of you have worked it 60.67. Yes. Mayur, Jyoti, Jan Lakshmi, and Muhammad Ali, thank you. Priyanka. So I hope you can see that in second case, the mean is almost same. Both have the same mean. But still, in the second example, you can see the mean is 60. But then the variation, one person has got 46, that means 14 marks below 60. Another person has got 82, that is 22 marks above 60. That means what? It is not uniform. Some people are too good, some people are too poor in performance. But here, if you see, 60 is the mean. One person, the person who has got the lowest is 55. So just 5 marks below 60. And the best person is 64. That is just 4 marks above 60. So this is a better performance. The distribution is better. That means they are close to the average. That means the people are more uniform. The students' performance is more uniform. As a class, this is better. If I talk about the whole class, now if someone asks me, out of these classes, which class is better in terms of highest marks? Well, highest marks here, 82, no doubt. There is one student in this class, group 2, who has got more than 80, and there is one more student who has got more than 70, 73. So in terms of individual, please note, in terms of individual performance, no doubt group 2 is better. If I talk about the highest marks, but if I talk about the general condition of the class, then group 1 is better. Okay, so why I'm saying group 1 is better in terms of the full class? Because the students' marks are more or less close to the average. But here, the marks of the students are scattered away from the average. Okay, I hope it is clear. Yeah. Dhyanesh has asked, what is deviation? Deviation means to deviate. That means to move away. Deviation means to move away. Okay. Like for example, you are driving your car or you are riding your bike, you have a GPS, you have a straight road from point A to point B, but suddenly you take a right turn and you think of going in a roundabout route. So you take a curve like this. That means you have deviated from the route. Okay, deviation means to move out. It is another name of dispersion. Okay. Now, why do we compute dispersion? I hope from this example, it is clear that group 1 is better on an overall basis. So let us see, it helps in comparison. You can see in the slide, in the study material also, it is given that it helps in the comparison. So just by looking at the values and the nature of the observations, we can easily understand that out of these two classes, group 1 is better in terms of performance. Similarly, if I give you another example, okay, very, very important. All of you know about share market and stock market. Okay, you are also studying about it in your BCK, business and commercial knowledge. Okay, now let me give you another example. Okay, so we will take two companies. Okay, company A and company B. Okay, I'm writing company A and company B. Both these companies, the shares are traded in the Bombay Stock Exchange. Okay, let us assume that both the shares are traded in the Bombay Stock Exchange. Now I am taking the price, market price of the share for 5 days. Okay, so 5 days in a week on the trading day, let us find out the market price of the share. So company A has a market price. Let me take here Monday, Tuesday, Wednesday, Thursday, and Friday. Here also I will write Monday, Tuesday, Wednesday, Thursday, and Friday. So we will try to see the share price. Company A and company B both are almost same in terms of size, in terms of revenue. Their balance sheet is very close to each other, and they are, say, for example, in the same industry. Let us assume they are in the steel sector. They manufacture steel products. Okay, so their companies are very close to each other. They are identical, quite similar. But let us look at the share price. Monday, company A share price 350, 344, 309, 300, 410. Please see the prices. Company B 410, 390, 393, 401, 408. Okay, imaginary prices, of course. Now, please see carefully the share price of company A 350, 344, 309, 300, 410. And company B's share price, this is company A, company B's share price on Monday is 410, Tuesday 390, Wednesday 393, Thursday 401, Friday 408. Which company's share is better? Company A or company B, and why? So let's see. Okay. Who will say? Which company share is better? Company A's prices you can see 350, 344, 309, 300, 410. And company B you can see 410, 390, 393, 401, 408. Okay, company B's share is better. Already some answers have started coming. Yes, already Kashish and Dhara Patel both have given the right answer. Company B's share performance is better because company A has wide variability. On one day, the share price is 309. And in 2 days, the share price has gone up to 410. So it is moving up and down very fast. But here, if you see in case of company B, okay, the deviation are lesser. It is close to the mean. It is close. So therefore, company B has less variability. It has less dispersion. So this is how we can just look at the marks. Here, of course, the share price, different type of data, and we can calculate, we can compute which one is better. So it helps you in financial decision making. So if you are an investor or as a chartered accountant, if you are advising your client which company share to be purchased, then definitely you will say that yes, for the investment purpose, company B is better. Why? Because the share prices are not moving too much. But in case of company A, it is falling also sharply and moving up sharply. So the variability is much more in company A, right? So therefore, yes, many of you have written answers also. Yes, very good. Or some people have, Dhyanesh has calculated the mean also. Om Singh, Pooja, Archana, Ankit, Piyush, Mansi. Okay, very good. Also, there's one more friend, Ansari, Abdul. Okay, very good. Thank you. Thank you. Good. So you have understood this concept. Very interesting concept. It is just opposite to central tendency. In case of central tendency, we were looking at the central value. Here we are looking at how much spread out the marks or the share price or whatever things are from the center, how scattered they are. That is dispersion. So it gives you nothing but an idea to take decision. Like if you see this point here, a higher value of dispersion means greater deviation. Definitely, more the dispersion, more is the scatteredness. Okay, more will be the deviation. Plus, we will look at variability, how to calculate variability. Right, different methods are there. We will look at mean deviation, and where there will be range, coefficient of range, and so on. It's a very easy chapter, and it's almost, I would say, it's easier than central tendency, because central tendency you had to remember so many formula, mean, median, mode, but here it is less, very easy. Okay, and you know mean, you already have good knowledge of arithmetic mean, so understanding mean deviation will be very easy. It's a very relaxing chapter and simple. Just carefully follow the 2-3 formula which you need to know, and rest will be very easy. So this is a practical chapter, and it helps you in decision making. You are able to choose the right decision out of some alternatives which are given to you. So dispersion means scatteredness or variability. I think it is clear now. It's a measure of dispersion is designed to find out how much variation is from the average. Like in the last example, we took the case where one student is getting 82, the average is 60.67. One student is getting 82, one student is getting only 46. So the variation is much more. But we measure the variation from where? From the center, from the mean, or it could be from the median also. Okay. So dispersion is defined as the amount of deviation of the observations, usually from the central tendency measure. So here, just think of these two practical examples which I was sharing. First one was the performance of the students, and the second one is the share price of two companies. Okay, so from there, you can understand that the deviation is measured basically from the central tendency, either from the mean or from the median. Look at the types. So there are two types. There is an absolute measure of dispersion, and there is a relative measure. Relative measure means there is something called percentage. We have to use percentage, right? So two methods, absolute and relative. Absolute measure is classified into range, mean deviation. Both of that we are completing today. And the third is standard deviation, and the fourth is quartile deviation. Standard deviation is written as SD in short. Quartile deviation is also written as QD in short. So SD and QD, that is standard deviation and quartile deviation, we shall be covering in the next session as per the session plan given by our institute. And range and mean deviation we are taking up today. Relative measures of dispersion, coefficient of range, which we are taking up today, and there are some simple measures like coefficient of mean deviation. So that also we will take up today. So coefficient of variation and coefficient of quartile deviation we are taking up on the next day. We will discuss on the next day. Okay, so in the absolute category, range and mean deviation we will complete today, and standard deviation and quartile deviation we shall be taking up on 23rd in the session on 23rd. Similarly, in the relative measure of dispersion, coefficient of range and coefficient of mean deviation we will understand today, and the two remaining part, that is coefficient of variation and coefficient of quartile deviation, we shall discuss on the next day. Okay, Now, absolute measures, basically, it depends on it's a direct calculation from the data. So we get the absolute measure. And the relative measure is used basically when we are comparing. For comparing two or more distributions, relative measures will be used. So sometimes it comes as a question that which technique will be used when we are comparing two distributions, like here two distributions, two data set. Okay. So I hope you are following, Dhyanesh and Dhara. I hope you are following now. I'm discussing about the difference between absolute and the relative measure, which you are asking. Yes, right. So you can see this is how we are actually finding out the relativity of two databases, which one is having higher variability, which one has lower variability. For example, in case of shares, it is always better if the company share is having low variability, because that will reduce the risk. But ideally, for investment purpose, for long-term investment purpose, for security purposes, safety purposes, a person should try to buy shares which does not have sharp movements, very sharp movements. But in the last example, in this example, you could see that company A is moving up and down very sharply, very high movements, and very low movement sometimes, it's falling steeply. But company B has a more balanced performance, right? So relative measures will be used for comparing, and relative measures, we have to just find the percentage. Okay. Now, one question can come, as I told you, that theory questions are important in statistics, and we should have the background knowledge of theory. So the ideal measure of dispersion, sometimes this comes as a question, MCQ, so it should be properly defined. Like in case of mean, median, and mode in central tendency, we had discussed about the definition. So it should be rigidly and properly defined. And we will find that almost all the measures of dispersion are properly defined. Easy to comprehend. Comprehend means understanding, right? So you will find that some of the concepts in this chapter, like range, for example, is very easy to understand. Simple to compute, yes, range, even mean deviation is easy to compute, and it is based on all observations. So in this chapter, when we will calculate standard deviation, mean deviation, or when we calculate range, it will be based on almost all the observations. Of course, range, in case of range, it depends on the highest and the lowest. But in case of standard deviation, we shall consider all the observations. And last but not the least, it should be possible to carry out mathematical treatment. So these are the ideal measures which should be there in any type of dispersion, any type of quantity by which we can find out the amount of dispersion. Now we start with the first one, absolute measure. So let us take the first case, range. Range is very simple. If I ask you, what is the range here? Share price. Range means the largest minus the smallest. So range here is what? The highest value is what? Highest price is 410. So I will write 410. And the lowest, I think, is 300 here. So the range is 110. It's simple. Just you subtract. In the second case, company B, you can see the highest price, L, is 410. And the lowest price, if we check, here also, I think the price is 390. The lowest is 390. Okay. So here you can see that 410 and 390. So the range we can see is 20. The range is 20. So in the first case, the range is 110. That means the movement is very sharp. The total range is 110. But in case of company B, the range is 20. So range is one way to find out how we are able to decide which dispersion, which type of distribution is more dispersed. So bigger the range, more is the dispersion. So this is the first example. Out of 5 numbers, 1, 3, 5, 6, 7, the range is largest value or the maximum value minus the lowest value. And then we will understand mean and mean deviation. So mean deviation means what is the deviation from the average, from the mean. We will do it through an example. Variance, we will take it up on next day. Please remember that variance means it is the square of the standard deviation. Just remember this for the time being, that there is a particular mathematical formula for variance. We will learn that, and variance is the square of standard deviation. Quartiles and quartile deviation also we will take up on the next day. So primarily we are looking at range and mean deviation. Now let us look at range. Simplest, very simple. Even a school student can calculate the range. You don't have to really learn statistics to understand range. Anyone can find out range. Simplest method. So range means the highest and minus lowest. So difference between the largest and the smallest item in a given distribution. So very simple formula, largest item minus smallest item. So range may be defined as what? You can see the difference between the largest and the smallest observations, number one. Number two is, thus if L and S denote the largest and smallest observation, the range is given by L minus S. Okay. Now for a grouped frequency distribution, very important. For a grouped frequency distribution, this is, you see there is no frequency. Okay, but if you have a grouped frequency distribution, what will happen? So if you have a grouped frequency distribution, say I'll take the case 10 to 20, 20 to 30, 30 to 40, okay, 40 to 50. And there are some frequencies, maybe 5, 7, 10, and 6. Okay, so this is the frequency. So in such a case, there is a class boundary 10 to 20, 20 to 30, 30 to 40, 40 to 50, and these are the frequencies 5, 7, 10, and 6. So here the range is defined as the difference between the two extreme class boundaries. So on the one hand, let us see the example here. First, let us see this example, and then we will take the second one. So here, the highest is 50 and the lowest is 10. So the range will be 50 minus 10, that is 40. Okay, so this is how we find out the range. Very, very simple. Okay. Okay, let me take one question from Dhyanesh. How ideal measure of dispersion unaffected by fluctuation? See, the ideal measure of dispersion will not have a very high coefficient of variation. So higher the fluctuations, the ideal measure should be such that even if there is a fluctuation, the ultimate ideal measure should not move up and down much, right? So it should be more or less controlled and close to the center. We will understand that later. So you just follow the session, you will understand it later. So ideal measure of ideal measure of dispersion should be such that it should not be varying even if certain observations vary. Okay. So here the salaries, the wages of 8 workers are given: 82, 96, 52, 75, 70, 65, 50, and 70. So we have to find out the range and the coefficient of range. Okay. Now let us know what is the coefficient of range. We will understand the value coefficient of range. First of all, please see 82, 96, 52, 75, 70, 65, 50, and 70. So here the largest number is 96. The smallest number is 50. So one of the worker is receiving 50 rupees. So it is the lowest figure. So the range is largest minus smallest. 96 minus 50, that is 46. The coefficient of range, let me just share this example. The coefficient of range. So I'm taking another simple, marks of 5 students in mathematics, okay, in CA Foundation. So let me take some marks here. So 63, 88, 92, 70, and 83. 63, 88, 92, 70, and 83. We will first find the range. So range is given by largest number minus smallest number. The largest number here is 92. I'll circulate 92. And the smallest number, the lowest score, if you see here, is 63. So 92 minus 63, that gives me how much? That gives me 29. Okay, 29. So this is range. Now the coefficient of range is equal to L minus S divided by L plus S into 100. Okay, this is the formula. So here, if you see, coefficient of range is how much? The range is 29. Okay, the range is coming to 29. 92 minus 63, 29. So the coefficient of range is how much? 29 divided by 92 plus 63. 92 plus 63 into 100. Okay, so let us just calculate this figure. So in the numerator, we have 29, and let me just find out the denominator, and we find out the value. So here we have the denominator 92 plus 63. So 92 plus 63, that gives you 155. So 29 by 155 into 100. So what we are getting is 29 divided by 155 into 100. So 18.7. 18.7 approximately. So this is how we are finding out. We are finding out the coefficient of range. Very, very easy. In this example, which you see from the study material, you can see, yes, range, many of you have got it right. Yes. Range is 29. Yes, absolutely. Very good. Coefficient of range. Muhammad Ali, Dhyanesh, then Mansi. Very good. Ompati, Ankit, Dhara. Very good. Yes. Now let us see the second example. Please see the second example on the slide. This is from the study material. So kindly note that the range and the coefficient we have to find out. Range, please note in this case, it is, kindly see that it is a frequency distribution. So the frequency distribution, please note, is discrete. Okay, it is not a continuous frequency distribution. So how to handle in this particular situation? So what to do? Let us see. Frequencies are given. So in this case, what we will do, we will make it continuous. 50 to 54, we can write as 49.5 to 54.5. So in this example, if I just write this, so it comes to 50 to 54, I will write it as 49.5 to 54.5. And the highest class is 70 to 74. So I will write it as 70, instead of 70, I will put it as 69.5 to 74.5. So therefore, the highest number is 74.5 and the lowest is 49.5. So I will just subtract. So range 74.5 minus 49.5, that is 25 kgs. And therefore, the coefficient of range is coming to 25 range divided by 74.5 plus 49.5 into 100. So we are getting coefficient of range is working out to 20.16. 20.16. Good, good. So many of you are working it out along with me. Great. Now we will move to the next example. Here again, you can see a problem on group frequency distribution. So 10 to 15, 15 to 20, 20 to 50, and 25 to 30. So you could expect these type of problems in the exam. So let us find out the range, and along with the range, we will also understand what will be the coefficient of range. Okay. So you can see in the classes given, 10 to 15 is the lowest class, 25 to 30 is the highest class. 10 to 15 means the lowest level is 10 and the highest class is 25 to 30 and the upper limit is 30. So therefore 30 minus 10, 20 is the range. 20 marks, the range is 20 marks. In other words, 30 minus 10 is the range. So the coefficient of range is given by 30 minus 10 divided by 30 plus 10 into 100. Okay. So if we work it out, just let us work it out and see. Range calculation we have done, and the coefficient of range comes to 30 minus 10 is 20, 30 plus 10 is 40 into 100. So it comes to 50. This is the coefficient of range in this particular example. Okay. Yeah, many of you have arrived at the right answer. Coefficient of range is 50. Manisha, Dhyanesh, Priyanka, Ansari, Chetan, Bhumika, Jyoti, Kashish, Chandan, Mansi, Ankit, okay, Muhammad Ali, very good. Abdul, very good. Excellent. Now range, the last problem on range, and then we will take a small break of 5-10 minutes, and then we will move into mean deviation. Okay, range calculation. Now, this is a very important question, very, very vital for the exam. If the relationship between x and y is given as 2x plus 3y equal to 10, and if the range of x is 15, what would be the range of y? So this is a problem which is very important, especially for your exams. Now, let us try to understand this relation. Now, this is something similar questions we have handled in the chapter on central tendency. So 2x plus 3y equal to 10, I will write 2x plus 3y equal to 10. That means I can write 3y is equal to 10 minus 2x. That is, y is equal to minus 2 by 3x plus 10 by 3. So please note that the coefficient of x is minus 2 by 3. So the relation you know is y equal to a plus bx. Y equal to a plus bx. Here a is 10 by 3 and b is minus 2 by 3. The formula which you need to remember is very simple formula. The formula is if the range of x is, say, let's call it r. Okay, so if the range of x is let's put it as x, I'll put it as r. If the range is r, then the coefficient, and then the range of y will be this b into r. So this b modulus b into r. Modulus b into r. So it is called mod. Mod means we will not consider whether it's positive or negative. We will take the absolute value. That is, in this case, we will take positive value. So here it means y is equal to minus 2 by 3x plus 10 by 3. So the range of y, I'm writing range of y is equal to mod 2 by 3 into the range of x. Range of x is how much? 15. So 2 by 3 into 15. That is 10. So this is very simple. Please note the solution which is given. Yeah, range is very easy. Yes, Dhyanesh, range is very easy, and you will find mean deviation also very easy. Okay, the range of y is given by 2 by 3 into 15, that is 10. Very important for the exam because similar questions have come in the mock test paper. And in the past few years, if you look at the exam questions, you will find quite a number of problems of this type. So, good question for the exam. Once again, you can see the coefficient of range formula, difference of extreme value divided by sum of extreme values, right? Now, the marks obtained. This is the last type of problem on range. So the marks obtained by 6 students are given. You have to find the range, and then you have to find if the highest marks is omitted, what is the percentage change in the range? So this is interesting question, and let us try to solve it. So you are given the score of 6 students, 24, 12. So let's just write it out. 24, 12, 16, 11, 40 and 42. 40 and 42. What is the range? So range, you know, is the highest minus lowest. So the highest value here is 42. Okay, and the lowest marks is 11. So the range is 42 minus 11, that is 31. So we have found the range. 31 marks. Now the question is, if the highest mark is omitted, find the percentage change in the range. So now we will omit the highest marks. 42 is not there. 42 is removed. So now what is the highest marks? If you remove 42, I'll just rub it out. If 42 is gone, then what is the highest marks? The highest marks is 40. So the new range R1 is equal to 40 minus 11. So 40 minus 11, that is 29, I think. Yes, 29. 29. So range, you can now get the range is 29. So how to find the percentage? So the revised range you can see is 29. So the change in the range, the original range was 31 and the change is 29. So 31 minus 29, 2 marks. So we can write the change is equal to 31 minus 29, that is 2 marks. And the original range was how much? 31. So therefore, the percentage change is 2 by 31 into 100. 2 by 31 into 100, that comes to around 6.45%. 6.45. 6.45. Very, very important question for the exam. Kindly keep a note of this particular problem and very, very important for your exams. So please note this working out. We have found out the highest value, the lowest value. From there, we have worked out the range. Range, we have got 31. But then the highest number is supposed to be removed as per the problem. So the next highest is 40. So the new range is 29. If 29 is the new range, so the change in the range is 31 minus 29, that is 2 marks. The original range was 31. So the percentage change in the range is 2 by 31 into 100. That gives you 6.45%. Okay. Yeah, many of you have correctly answered it. Mayur, Om, Dhyanesh, Chandan, Ankit, Jyoti, and others. Very good. Now the last. So this is over. Range is over. So I told you it's very easy. So advantages of the range, you can answer it yourself. Range is easy to understand, simple to calculate. Okay, this is again from the study material. And second disadvantage of range is it is very much affected by extreme values. If there is one extreme value, right, instead of, say, here the range was 31. Now, instead of 42, if the marks is very high, say somebody has got 72, the moment it becomes 72, you can see the range will become 72 minus 11. It will shoot up, it will become 61. So extreme values will have a high impact on range. Also, it does not depend on all the observations because range means the highest minus lowest. So range does not depend on the observations which are coming in between. Please note here, if I write 42 as the highest marks, and the range is what? The range is highest minus lowest. So virtually highest minus lowest. The observations which are coming in between does not matter. So this is a disadvantage of range. Why? Because the ideal measure of dispersion should take into account all observations. Okay, it should not be focused only on one or two observations. It must consider all the observations, all the marks, or all the figures which are there. Range cannot be computed in case of open-end distribution. Yes, if the class intervals say it's open-ended. So if it is given that 60 to 70, 70 to 80, 80 and above. So if the class boundary is not given, if it's open-ended, then you cannot calculate the range. Uses of range, quality control. How it is used in quality control? So in quality control, say in a company where there is some production going on, some manufacturing going on, so the manager will decide that, okay, the maximum range will be, say the average thickness, the target thickness. Say they are manufacturing, say for example, some steel plates. So the ideal thickness, say it is 2 inch. So what will happen? They will give a range. So maybe the target thickness should be, say, 2 inch. Okay, 2 inch. And then the manager will say that, okay, even if a particular steel plate is having 2.04 inch, we will accept it. That is the highest, H. And on the lowest side, if a steel plate is having 1.98 inch, then also we will accept. So you can get the highest and the lowest, so you get the range. So range is used in the field of quality control in production and manufacturing. Okay. Okay, Dhyanesh is saying no break. Okay, then we continue. Okay, so this is then we will definitely complete before 4. You will already have been working since morning. So now we move on to the, I'm not usually in favor of break, but why? Because in a break, what happens, the tempo, the momentum gets disturbed. So we should continue with the same momentum. Now we move on to the last point. In stock market fluctuations, range is used. Yeah, you know, in stock market, the highest value is this, the highest share price, the lowest price for the share is this, so we can get a range. Now mean deviation. Mean deviation is interesting, just like range. Mean deviation means the distance or the deviation between individual observations from the mean. Okay, let me take a simple example. Okay, and we will calculate it, mean deviation. So let us take, I'm just taking random numbers. Let it be the marks. Okay, let it be the marks of students in mathematics paper in CA Foundation, some students' marks. So student number 1, S1, 2, 3, 4, 5, 6. I'm taking 6. I'll try to work it out. So the first student, this is marks. The first student has got 75, 80, 60, 45, and the last student has got 90. Okay, fine. So first, let us find out the range. Range is very easy. It's just we have completed range. So highest marks is 90 and the lowest marks is 45. So the range is 90 minus 45. So I'm writing range is 45, 90 minus 45. But now let us find out mean deviation. How do we find the mean deviation? First is we find the mean of these marks. So I'm trying to find the arithmetic mean of all these observations. You know, it is given by the summation, the total sum divided by the number of observations. Here it is 6, 1, 2, 3, 4, 5. You've taken 5. Okay, 1, 2, 3, 4, 5. So sum divided by 5. So let me just add up the marks and find out what will be the total. So 75, so it is 80 and 60 is 140. So we have 140 plus 75 plus 45 plus 90. So we are getting 350. Total comes to 350 divided by 5. So I'm getting mean comes to 70. The average comes to 70. Now please see carefully. Mean deviation. So now we will find x minus the average, x bar. This column will be x minus x bar. So each of the observation, the arithmetic mean AM is equal to 70. So what is the mean deviation? That is the deviation from the mean. 75, the mean is 70. So the deviation is how much? 75 minus 70, that is 5. Second observation is 80. Your mean is 70. So the deviation is 80 minus 70, that is 10. The third one is 60. The mean is 70. So here also we will take the value without considering whether it's positive or negative. So 60 and 70, the difference is 10. 45, the mean is 70. 70 minus 45 is how much? 25. So I'm writing 25. And 90 minus 70 is 20. Now I will add up all this. 5 plus 10, 15 plus 10, 25, 25 plus 25, 50, 50 and 20, 70. We have got here 70. So from here we can find out the mean deviation. So mean deviation means, mean deviation, MD, mean deviation means the total deviation, that is 70 in this case, divided by the number of observations, that is 5. So I'm getting a mean deviation of 14. 70 divided by 5 gives you 14. Please see this calculation. I took this is not in the slide. I just took it by assuming certain figures and we have done it. Okay, AM is 70 and we have got 70 is the mean. Yes, 70 is the mean, absolutely. I have taken 5 students, yes. Minus is not taken, Dhyanesh, because please note, for finding out, if you take the minus sign, what will happen? If you take plus minus, then you will get 0. Okay, you will find 0. For example, if you really take the plus minus here, okay, what would have happened? 75 is more than 70, so it is plus 5. 80 is 10, but then 60. This 60 means it is less than the average. So 60 minus 70 would have been minus 10. 45 minus 70 would have been minus 25. And 90 minus 70 is 20, that is fine. Now, if you find out what happens, 5 and 10 is 15. 15 and 20 is 35. But then 35 and minus 35 gives you 0. So if you look at the plus sign, minus sign, if you consider the sign, then you will always get 0. That is the formula of the mean. If you consider the plus sign, minus sign, you will always get the total deviation will always be equal to 0. But we want to find out the absolute measure. Absolute means without considering minus sign or plus sign. We will actually take the plus sign, the positive deviation. We will ignore the negative sign. So here, if you ignore it, then we get 70, and therefore the mean deviation comes to 14. Yes. So I hope, Dhyanesh, you are now clear. Ankit, Mansi, thank you. Bhumika also has done it correctly, I think. Okay. So this is the concept of mean deviation. You can calculate mean deviation either from the mean, if the question tells you, or you may calculate mean deviation from the median. Okay, both are allowed and both might come in the exam depending on the type of question. Now, for a given set of observation, mean deviation, that means what? It is the arithmetic mean of the absolute deviation. Please see, I'm just putting the cursor on the word absolute. It is the absolute deviation of the observation from the mean. Here we took the mean. Mean is 70. From there we find out the deviations, and then we have added it up. We added the deviations. We have got 70 here. Number of observations we have taken is 5 observations. So 70 divided by 5 gives you 14, which is your mean deviation. Sometimes median is preferred, again, due to certain reasons, because the sum of the deviations from the median will be less than that from the mean. So lower the deviation, better it is. So sometimes median is used. Mode is never used. Mode is not considered because mode sometimes is not possible to calculate. Why? Because if the frequencies, you remember mode means highest frequency. If the frequencies are equal, then there is no mode. So there are certain cases where mode cannot be found out, so mode is not used. So mostly in this mean deviation, it will be the deviation from the median, and it can be deviation from the arithmetic mean. And please note, mean deviation is known as the first moment of dispersion. First moment of dispersion. Right. Now, coefficient of mean deviation. Very simple. Mean deviation about mean by mean into 100. So in this example, which we have taken, you have got mean deviation is 14. So what will be the coefficient of mean deviation? It will be 14 divided by mean, which is 70. 14 by 70 into 100. That gives you 20%. You will get 20%. 14 5 is 70, I think. Yeah. And therefore, it gives you 20%. So coefficient of mean deviation is the mean. Here it is mean deviation, of course, it is 70. Mean deviation about mean. Just a moment. Mean deviation. The mean deviation about mean is 14. Okay. The total deviation is 70 and the mean deviation is 14. Mean deviation by mean. So 14 by 70 into 100. That gives you the coefficient of mean deviation. Yeah. Very good. Steps to find the mean deviation. First, let me take another example here. We will take one more complete example. So this is a very scoring chapter. You can find out it's very scoring chapter, and most importantly, the problems are very easy, and just you need to be cool and calm. Don't hurry and don't have any tension. Relaxed in a relaxed manner. Just go on solving. So let me take one more example where we will do all the calculations, and we are taking, say, some say marks again. We'll take marks in accounts paper. So we will take accounts paper marks. So 1, 2, 3, 4, 5, 6, 7. This time we will take 7 students. The first person has got 80. Second person has got 66. Third person 58. Fourth person 82. Fifth person, say for example 73. Sixth person has got 80, and the seventh person has got 55. We have to find all the things: range, coefficient of range, mean deviation, and coefficient of mean deviation, all. Okay, so first let me find out range. This is again a problem not there in the study material, in the presentation, not in the study material. I'm just creating the the problem here, and we will try to solve it. Here the highest marks is 82. Please note it has a mode. Two people have got 80, so mode we can find out. Okay, so now 82 is the highest mark, so range is equal to 82 minus lowest marks. The lowest marks is 55, so 82 minus 55, that is 27. This is the range. R, range, coefficient of range, just a moment, I'll write coefficient of range. This is equal to 27 divided by 82 plus 55. So it is 82 plus 55 multiplied by 100. So let me just work it out. 82 plus 55 is how much? Just let us work it out and calculate and see. 82 plus 55. So 82 plus 55 gives you 137. So in the numerator we have 27, denominator 137 into 100. So it is 2700 divided by 37. Sorry, 137. Yeah, it's 137. 2700 by 137. So you can just get it. It's coming to 19.7. 19.7. So range we have calculated. Now we will calculate the mean deviation. So first part we have done. The range is coming to 27, and I'll write it here. Range equal to 27. Coefficient of range is 19.7. Now I will rub this part. Now we move to the next calculation, and this will be the calculation on mean deviation. Okay. Yeah, very good. Range is 27. Thank you. This is Jyoti. Yeah, Jyoti, thank you. 27. Acha. Now we will find mean deviation. Mean deviation. So we will first find out the mean. So 80, just let's calculate the mean together. So we sum up all of them. I will write AM. We have to find the arithmetic mean, and you know the formula. We just add up all the numbers here. So just adding up 80 plus 66 plus 58 plus 82 plus 73 plus 80 plus 55. The total sum comes to 494 divided by 7. There are 7 students. 1, 2, 3, 4, 5, 6, 7. So we are getting 70.57 as the average. Arithmetic mean is 70.57. I will round it off as 71. I'll take it as 71. Okay, 71. So now we will find x minus x bar. Okay, that is each of the observation minus the mean. 80 minus 71, difference is 9. 66 and 71, difference is 5. 58 and 71, the difference is 13. 82 and 71, difference is 11. Okay, in this way, please work out with me. 73 and 71, difference is 2. 80 and 71, difference is 9. 55 and 71, the difference is 16. So now we will add all this. Okay, so we are going to add this entire column. So what do we get? What is the total mean deviation? So we are getting 9 and 5. 9 and 5 is 14. 14 and 13 is 27. 27 and 11 is 38. 38 and 2 is 40. 40 and 9 is 49. 49 and 16 49 and 16 is 65. So the total mean deviation is 65. Okay, divided by 1, 2, 3, 4, 5, 6, 7. So 65 divided by 7. So let us, it comes to around 9. So I will take a round, I'll take a round about 7 9s are 63. So I'm taking mean deviation comes to 9. If mean deviation is 9, then the coefficient of mean deviation is equal to MD by mean into 100. That means it is here 9 divided by the mean is 71. The mean is 9 by 71 into 100. That means you are getting 900 divided by 71, 12.67. 12.67. This is the mean deviation. Okay, so let us look once again at this. So mean deviation approximately, I have rounded it off. So MD has come to 9.28 or 9. I have just for sake of calculation. And the coefficient of mean deviation 9 divided by 71 I have taken. So that gives me around 12.67. So this is basically the process. So we have got the, from here we found out the mean first. Once you have got the mean, the next step, if you just see once again, we got the mean from here, the mean came to around 71. So from each of the observation, we have subtracted, we have found out the deviation, the difference between each of the observation and the mean. So we got these numbers, we add up these numbers, we are getting 65. But then the mean deviation means the total deviation divided by the number of observations. Here the number is 7. So 65 by 7. So I've got around 9 point something. I have taken it as 9. And then 9 in the numerator, mean is 71. 71 in the denominator. 9 by 71 into 100. So approximately 12.67. Okay. So the process is very simple. Once again, if you look at the slide now, find the mean or median. We have done it. Take the deviation. Please see second line, second point. I have introduced, I have just put it, I have underlined it just to draw your kind attention. Take the deviation ignoring the plus sign and minus sign. Here we have taken the deviation by ignoring. We are just worried about the deviation, not the sign. Get the total of the deviations. Yes, we have got the total. It comes to 65 and then divide by the total number of items. 65, total number of items is 7. So 65 by 7, we have got 9 approximately. Okay. Now let us take one example from the study material. Okay. What is the mean deviation about mean for the following numbers? Okay, 5, 8, 10, 5, 8, 10, 10, 12, 9. What is the mean deviation about mean for the following numbers? 5, 8, 10, 10, 12, 9. So we first find out the mean, very similar to what we have done already. The mean comes to 9 here. And now you can get the mean deviation. In the slide, you can see that the mean deviation is given. 5 and 9, the deviation is 4. 8 and 9, deviation is 1. In this way, the total deviation comes to 10. The number of items here is 6. Number of observations are 6. So 10 by 6 is 1.67. That gives you the mean deviation. Okay. Now let us take a combined example. That's why I have also, in this last problem, I have also shown range and coefficient of range so that you get, I told you it will be comprehensive example, which will include all the parameters we have learned. Range, coefficient of range, mean deviation, and the coefficient of mean deviation. Okay. Now this is a combined problem on mean and median. Okay, so we will try to solve mean and median together. So 2, 6, 11, 14, 16, 19, 23. Okay, so let us try to solve it through median. Okay, let us take the median part. Okay, now here we will take median. Mean we have already done few examples. Let us try and take median. So here the Center will be the median. So 2, 6, 11. So 2, 6, 11, 14, 16, 19, and 23. How many observations? 1, 2, 3, 4, 5, 6, 7 observations. 7 observations are taken. Now, in order to find the median, we know the formula is n plus 1 by 2, n plus 1, so n plus 1 by 2. Here n is 7. So 7 plus 1 by 2, that is 7 plus 1 is 8 by 2, that is fourth observation. So the fourth observation. So 2, 6, 11, 14, 16, 19, 23, it's in ascending order. 1, 2, 3, 4. Fourth observation is 14. Okay, so we are taking median as 14. We are taking median as 14. So now x minus median. Of course, we will take the absolute value. 2 and 14, the difference is 12. 6 and 14, the difference is 8. 11 and 14, the difference is 3. 11 and 14, the difference is 3. 14 and 14, the difference is 0. 16 and 14, difference is 2. 19 and 14, the difference is 5. And 23 and 14, the last one, 23 and 14, the difference is 9. So now if you find out the total of this one, 12 plus 8 is 20, 20 and 3 is 23, and 2 is 25, 25 and 5 is 30, 30 and 9 gives us 39. So we are getting 39. Okay, 39. Please note 39. Once I'm getting 39, I have to find out mean deviation, but this is mean deviation about median. So the mean deviation about median, that means from the median we are finding out, it is 39 divided by 7. 39 by 7, let us just work out and find out the exact figure. We have 39 divided by 7, it comes to 5.57. So I'm getting 5.57. So now the coefficient of mean deviation, but this is about median. Please note, here the guiding line is median. So this comes to mean deviation, it is 5.57 divided by median. What is the median we have calculated? Median is 14. So 14 into 100. So 5/57 divided by 14 into 100. So we are getting 5/57 by 14 into 100. So approximately 0.40, or you can say it is around 40. Okay, you can just multiply that by 100. It will come to 5.57 by 14. So 5.57 divided by 14, 5.57 divided by 14 into 100, that gives us approximately 40. Okay, or 0.4. So this is how we calculate mean deviation about mean and mean deviation about median. Okay, so I hope you are following. Yes, 5.57. Ajit Abu, Bhumika, Ankit, Dhyanesh, Dhara, Mayur. Yes. Okay. So I think there's one question. Yeah, Janlakshmi, I think you could explain the. I hope you are able to follow this. How we have found out. Okay, we have taken mean deviation from the median. Let me try it out with mean once again. And Janlakshmi, for you especially, I'm doing this. Please see the working out once again. Okay. So we are doing the same, but this time we are trying it from the mean. Okay. Now 2, 6, 11, 14, 16, 19, 23, we have to find the arithmetic mean. Very important question for the exam. This type of questions are expected. So here we will just find out the mean. So the total comes to 2 and 6 is 8, 8 and 11 is 19, 19 and 14 is 33, 33 and 16. 33 and 16 is 49, 49 and 19 is 49 and 19 is 68, 68 and 23 is 91. 91 divided by 7. So arithmetic mean is 13. So AM is coming to 13. So now arithmetic mean is 13. So I will find x minus x bar. 2 and 13, the gap is 11. 6 and 13 it is 7, 11 and 13 it is 2, 14 and 13 is 1, 16 and 13 the deviation is 3, 19 and 13 deviation is 6, 23 and 13 deviation is 10. So now we add up all of them. 11 and 7 is 18, plus 2, 20, plus 1, 21, plus 3, 24, 24 and 6 is 30, 30 and 10 is 40. So the mean deviation, MD, around mean, from the mean, because we are taking mean from the mean, this is equal to 40, so 40, divided by number of observation 1, 2, 3, 4, 5, 6, 7, 40 by 7. So let's find out how much it comes to. 40 by 7. 40 divided by 7. So we are getting 5.71. 5.71. So therefore, the coefficient of mean deviation is 5.71 divided by mean, which is 13 into 100. If you multiply by 100, you will get, basically, you are going to get round figure. So it comes to around, if I take it as into 100, so around 43. So 43 approximately. Okay. So 43.8 rather. 43.9, yeah, 43.95, or almost 44, 0.44 or 44% of course. So this is how we calculate mean deviation, and from the mean, also from the median. I hope it is now clear, and I hope you can calculate it. Okay. Let me take one question. MD is coming. 39.7. Yeah, approximately. The calculation, of course, is definitely not that important. Ultimately, the formula, because the formula is you are using, anyhow, you are using a calculator. Okay. There's one question from Dhyanesh. Why it is called mean deviation about median and why not median deviation about median? It confuses in the exam. Okay, good question. I was expecting this question. Now, in this example, let me go back to the last slide. Please see, Dhyanesh has a very interesting question that when we are finding out the deviation from the median, we should say median deviation from median. That is what he has written also. Why do we call mean deviation about median? Mean deviation, mean means what? Average. So when we calculated, so I hope Dhyanesh is watching. So when we calculated in the last example, when I was working on the median part, or you can see the calculation here, please note from the median comes to 14. Okay, the median is 14. I'm just putting my cursor here, 14. And if you look at the deviation from the median, ignoring the sign, it is 39. But after 39, what is the next step? So Dhyanesh, try to see what is the next step after 39. We are dividing this 39 by 7. You can see we are dividing. Please come to this step. Why it is called mean deviation? Because 39 divided by 7 we are doing. Why? This 7 means what? We are finding the arithmetic mean. It is the mean of this deviation. Total deviation is 39 and we are finding the average deviation. So it is called, average is also known as mean. That is why we write in both the cases mean deviation, mean deviation. But in the first case, the deviation was from arithmetic mean. So we write mean deviation about mean. It will be given in the exam. And if the exam question says it is mean deviation about median, then you consider the median. So there is no confusion at all. The question will tell you in both the cases, the term used is mean deviation, no doubt about it. But in the first example, they are going to tell you whether it's from the mean or from the median. Here in the first case, we have done the deviation from the mean. And in the second case, we have calculated deviation from the median. Therefore, we are getting this answer. Okay. So I hope it is now clear. Okay. Now we will take just 3-4 questions and then we will go to the MCQ. To calculate mean deviation of the following series, we have to find the coefficient of dispersion, also known as coefficient of mean deviation. So a series is given to you, calculate mean deviation of the following series. So we will take it, we will assume that we have to find the mean deviation from the mean. Okay, so we are trying to find the mean deviation from the mean here. And in order to do it, please note the steps here. First, we have taken, there is a frequency. Okay. So we are getting a frequency. So frequency means we have to, in the last example, please note, I will go back to the last example. So there was no frequency. But if you get a frequency like this, what to do? So we will work on the mean deviation from the mean. And we will work out the entire steps here. And then we will compare it with the solution which is given, and we will check whether we have done correctly or not. So here, please note that we are getting certain frequencies. Frequencies means there will be a multiplication of frequency and the digits which are given, the frequency and the observation. So first, let us write down the table here. So 5, 10, 15, 20, 25, 5, 10, 15, 20, and 25. Frequency F is 6, 7, 8, 6, 7, 8, 11 and 8. 11 and 8, total comes to 40. Fine. So we have to think of the formula of the mean, which we have done earlier, using assumed mean. So the best way is to use assumed mean. Or if you want, you can go by the other formula, that is multiplication of the frequency with the x. That also can be done. Let us try it out in that method only. Let us try sigma fx. So 5 6 are 30, 10 7s are 70, 15 8s are how much? 15 8s are 120, 20 into 11 is 220, 25 into 8 is 200. So let us add up and see what we are getting. We are trying to find the mean. Okay. But the question will be, even if we get the mean, there will be a problem later on. So let's just try to find the mean first, but there will be some complication later. So we are taking 30 plus 70, that is 100, 100 and 120, that is 220, 220 and 220 is 440, 440 and 200, 640. So the total is 640, and the total number of frequency, it is 40. So the mean should be 640 divided by 40. That is 16. Mean should be 16. Okay. Now, either this way we do it, or we use the basic way, that is basically using, we can just work using the assumed mean. So if we use the assumed mean, what we will do, we will take 15. Well, let us take the midpoint, 1 2 1 2. So midpoint is 15. So let us take assumed mean as 15. Now we know the formula. Assumed mean, if it is 15, then the deviation x minus x minus a. Assumed mean is a. So what do we get? 6 and 15. So we are having 5 and 15, that is 10. 5 and 15. 5 minus 15 is minus 10. 10 minus 15 is minus 5. 15 minus 15 is 0. 20 minus 15 is plus 5. 25 minus 15 is plus 10. So we have got this deviation. That is, we can write it as d. Now we will find d dash. D dash is how much? D dash is the deviation divided by the class. 5 to 10, 10 to 15, so the class is 5. So d dash is equal to d by 5. Minus 10 by 5 is minus 2. Minus 5 by minus 5 is minus 5 by 5 is minus 1. 0 remains 0. 5 by 5 is 1. 10 by 5 is 2. So we have got FD dash. So D dash is got, we have already got. Now we will find FD dash. That is frequency, since the frequency column is there. Frequency into the deviation. 6 into minus 12, that is 6 into minus 2, that is minus 12. 7 into minus 1, that is minus 7. 8 into 0, so it gets 0 here. 11 into 1 is 11. 8 into 2 is 16. So now we find sigma FD dash. So we are trying to find sigma FD dash. That is coming to minus 12 and 7 minus 19. Minus 19 plus 27. So it comes to 8. Fine. Okay. So we have got up till here, and now the last column we need to fill up, and that is the frequency into x minus x bar. frequency into x minus x bar. So first of all, we find out the arithmetic mean, and we just work out to find out the arithmetic mean here. Arithmetic mean, as we calculated earlier, is 16. So here also we get 16. So now we will find f into arithmetic mean. Already we had got 16 earlier. Here also it is coming to 16 using this method. So now we will find f into x minus x bar. So the frequency which is given here 678 multiplied by the deviation. So here we have 6 and the mean is 16. So therefore the difference comes to 16 and 6. You have to find the difference, that is, it is coming to, first of all, sorry, it's 5. First observation is 5 and 16. So it is coming to 11. X minus x bar we are doing 11. Next we have 10. Mean is 16. So the difference is 6. 15 and 16 difference is 1. 20 and 16 difference is 4. And 25 and 16 difference is 9. Now we multiply this, the last column, this by frequency. So 11 into 6 gives you 66. I'm circling it. 6 into 7 gives you 42. Circling it again. 1 into 8 is 8. Circling it again. 4 into 11, 44. A circle. 9 into 8, 72. Again a circle. This total comes to 232. So from here we can find out the mean deviation. Mean deviation is the total deviation divided by the total frequency, which is 40. So I will just rub up this portion. This is not required anymore. So the total, we know the total frequency is 40. Mean deviation is therefore equal to 232, which we have got, divided by 40. That comes to around 5.8. And if we know the mean deviation, then the coefficient of deviation is how much? The coefficient of deviation, or sometimes called coefficient of mean deviation, is equal to this 5.8 divided by the mean. Now mean, it already we had got it correctly. It was 16. 5.8 divided by 16 into 100. So the mean deviation is coming to 36.3, or you can put it as 0.363. If you don't multiply by 100, 0.363, or it comes to around 36.3. So this is complete example of how we are doing it in case there is a frequency. Okay. AM is 16. Ankit, I hope you have understood how we arrived at 16 using two methods. First was the weighted average. Second was the assumed mean. Both are coming to 16. And then you found you got the total frequency was 40. Total deviation came to 232. So 232 divided by 40, you get the mean deviation 5.8, and then 5.8 divided by mean into 100 gives you the coefficient of mean deviation. We will take one more example also so that you are absolutely clear. Now, this is a question, find MD and AM. So it is given AM. Let us try it out and see whether we can solve it. They have said, calculate also MD about median and hence find coefficient of mean deviation. So we have to do both. Okay. So let us work it out. This is the last problem, and then we will go into the MCQ and complete. So find MD and AM of the following frequency distribution. So 3.5 to 5.5, it's a continuous frequency distribution. Please note, we are trying to calculate median first. Let us take median. So 3.5 to 5.5, 5.5 to 7.5, 7.5 to 9.5. So it's a continuous distribution, 9.5 to 11.5 and 11.5 to 13.5. Okay, this is from a past question, not from the exercise, additional question. So possible you can just work it out. Number of workers given, frequency 6, 14, 16, 10 and 4. We are doing mean deviation from median. Please note. The last example we have done arithmetic mean. Now, okay, please try to see this. Please try to see carefully. Dhara, please try to see how I'm solving it. Okay. So it is a class boundary given and the frequency are given. We are calculating median first. So median, if we have to find the median, now what we will do is we will have to find out the total frequency. Okay, total frequency we have noted. We have to find the cumulative frequency, CF, cumulative frequency. So for the cumulative frequency, this is 6. 6 plus 14 is 20. 20 and 16 is 36. 36 and 10 is 46. 46 and 4 is 50. Okay, in this type of situation, you know the formula is n by 2 in grouped cases. So n by 2, here 50 by 2, that is 25th observation will be the median. 25th observation, n by 2, 25th observation. 25th observation means it is somewhere here, between 20 and 36. So the median class is this one, 7.5 to 9.5. And the median will be calculated ME. Median is equal to lower limit 7.5 plus this 25 minus 20. 25 minus 20, it goes in the numerator. In the denominator, it is 36 minus 20. 36 minus 20 into the class width is 2 into 2. So I'm getting 7.5 plus 25 minus 20 is 5. 36 minus 20 is 16. 5 by 16 into 2, 2 8s are 16. So I'm getting 7.5 plus 5 by 8. 7.5 plus 5 by 8. Let us just work out and see how much we have got. 5 by 8. So 5 divided by 8 is equal to 0.625. 7.5 plus 625 plus 7.5. So just let us check. So we are getting approximately the median using the formula which we have done here. We are getting the median. Just a moment. Yeah. Just let me show you the median. So the median is around 8.12, which we have got. 7.5 plus 0.625, 8.12, we have already got it. 5 by 8 is around 0.625, 8.12. So now we have got the median. Okay. Now we have to find the mean deviation about the median. So here we can see the mean deviation about median. Now this is the toughest part in this chapter. So just look at the table. So I'm just rubbing this part. Mean deviation is the median is 8.12. I'm just writing median is 8.12. From each of this class boundary, now we have to find the mid value. So it will be 4.5. 5.5 to 7.5 is 6.5, then you have 8.5, then you have 10.5 mid value, and 11.5 and 13.5, it will be 12.5. Mid value we have got. The mid value we have got. Now the deviation we have to do. What is the deviation? Each of the mid value. What is the distance between the mid value and the median? Median, please note, is 8.12. So 8.12 and 4.5. So just you have to calculate. 8.12 and 4.5. How much is coming? So just try and work it out. 8.12 minus 4.5 approximately comes to 3.625 approximately, or 3.63 as it is in the. So the deviation D is equal to 3.63. Second one, 6.5 and 8.12. So 8.12 minus 6.5, 6.5. It's 1.62 or 1.63, whatever. I'm getting 1.62 something. Okay, in this way, you have to fill up all these points. And then you multiply with the frequency which is given. Please note, we will multiply basically with what? We are going to multiply all these numbers with the total number which we have got here. Okay, so in this example, we have got, it's come to 1.62, for example, and 1.62 into, we just multiply 1.62 into the frequency. Just find out. So the frequency is 14. So let me just multiply 14 into 1.62. 22.7. It's coming to 22.7 or 22.8, whatever as in the problem, 22.7. So you multiply each of these deviations, 3.63 into 6. Don't take the cumulative frequency, only the individual frequency. 14 into this, 16 into this. So you will get the total here in this way, which you can see on the right hand side, the last column. Okay, the last column. So in this way, what you can do is like 3.63 we have got here, and the frequency is 6. So 6 into 3.63, how much does it come to? 6 into 3.63. It comes to 21.78, 21.78. In this way, we have to find out the deviation in this column multiplied by the frequency. Please don't take the cumulative frequency now, only individual frequency. You will get the total value here. That gives you the total quantum of the deviation, which is 91.70. So, and 91.70 divided by 50 gives you the mean deviation from the median. Okay, so this is how we solve this, and the mean deviation is worked out. You can see 91.70 divided by 50, so you get 1.83. So the coefficient of dispersion from the median, the formula is MD, the mean deviation which we have got. So coefficient of deviation, that is coefficient of deviation from the median, not the mean. We are calculating from median now. So here it will be the total amount which we have got. Total amount is how much? 1.83 divided by the median itself. What is the median we calculated? The median came to 8.12 or 8.13 approximately. I'm taking 8.12. So 1.83 divided by 8.12. You can multiply that by 100 also. So 183 divided by 812, 812, approximately 0.225, 0.225. So we have got the coefficient of mean deviation, but it is from the median. So we worked out the median using the formula n by 2. We got the median formula and then we solved it out. Last one, if x and y are related as this, very important question from the exam. Okay, then one question, how Ankit is asking 3.63 kaise aaya? Okay, how it has come? Which 3.63 you are talking? I think this 3.63 which I wrote here, 3.63. The deviation, 3.63 came from the deviation. Ankit, please check. The median in the example was 8.12. We have already worked it out here. 8.12 is the median. You can see we wrote it here. And the first observation is what? 3.5 to 5.5. So the mid value is 4.5. 8.12 minus 4.5, if you do, you will get approximately 3.63. So in this way, we got 3.63. And that's how we calculated each of the deviation. Okay. Akshat, welcome to the class. Now you can join the live class. You can check the, you can just check the link live.icai.org/BOS/VCC. You just go to ICAI website and just go to the search, and there you can search for the live classes for foundation. They will give you the link. Okay. And you can also check the videos in ICAI CA Tube once it is uploaded. Also, you can see the live streaming. Right. Now let us take this example, very important for the exam. If x and y are related like this, what is the mean deviation of y? Very, very important. So the formula is same. These questions are expected for the exam from this chapter. Very, very important questions. The relation is 4x plus 3y, 4x plus 3y plus 11 equal to 0. Please note. What we do, we know the formula is y equal to a plus bx. Y equal to a plus bx. Mean deviation of x is given. You have to find mean deviation of y. And the formula for finding out the mean deviation of y, if I write y MED, mean deviation, this is equal to b into the mean deviation of x, x MED. This is the formula. Y mean deviation, you have to find out, that is equal to modulus b. this B into X median, X mean deviation. So now what we do is we find out from this equation, please see, I'll work it out. 3y is equal to minus 11 minus 4x. 3y I keep on the left hand side, 11 and 4x I bring on the right hand side. So therefore I'm getting y equal to minus 11 by 3 minus 4 by 3x. Please note, it is now of the form a plus bx, where b is minus 4 by 3. So I'm getting y equal to minus 11 by 3 minus 4 by 3 into x. So please note, it is of the form a equal to y equal to a plus bx. Here a is equal to this part, that is minus 11 by 3, and b is equal to minus 4 by 3, minus 4 by 3. Because minus 11 by 3, I can write it like this, minus 11 by 3 plus of minus 4 by 3 into x. A plus bx. Here b is minus 4 by 3, minus 4 by 3. So now we have got the answer. Here we have to find y mean deviation. B, we have already got B. B is minus 4 by 3, but we have to take the modulus. So we ignore the sign. We will take 4 by 3 multiplied by x mean deviation. The mean deviation of x is given 5.4. It's given in the problem. So 4 by 3 into 5.4. I think that will come to 7.2. 3, 1.8 into 4. 7.2 should be the answer. Let us check. Yeah, 7.2. One of you have got it. Dhyanesh, good. 7.2. Very important question for the exam. Lastly, we look at advantages of mean deviation. It is based on all observations. Any change in any item definitely will have an impact, because we are calculating the mean. It is all readily understood. We found out the mean and we found out the deviation. It is easy to calculate. However, mean deviation from median, I will agree that it is a little bit more confusing, but just a little more practice on your side and do a couple of questions. You will definitely have more command over calculation of mean deviation from median. And disadvantages is we ignore the algebraic signs of deviation. That is true. It is not an accurate measure, because if it is calculated from mode, again, it will not be an accurate measure. Lastly, we move into the questions. Now, please note that mean deviation is important for not just only for economics, but even in finance, for forecasting in business, for finding out, like, for example, we were calculating which observations are more uniform, which observations have higher deviation. Everything can be calculated from mean deviation. So some questions, daily wages is given 12, 8, 9, 10, 7, 14, 15. Calculate the range. You can do it just verbally. You can see the highest is 15 and the lowest, I think, is 7. So range comes to 8. Similarly, in this case, range, you have to find out. You are given the values. Here also you can do it mentally. Highest is 64, you can see, and the lowest is 39. So 25. Okay. Similarly, the third example on range, these are exam type questions. Just before we wrap up, just a few questions. Marks obtained is given 24, 12, 16, 11, 40, and 42. Find the range. And this type of question, I think we just did this question. Yeah, so that we have already solved it earlier. Acha, mean deviation problem number 1. Let us solve this. From the following frequency distribution, find MD about median. Find MD about median. Just let us try and do it. One or two of you requested me to solve one more problem, so please see this working out. Class interval is given 2 to 4, 4 to 6, 6 to 8, 8 to 10. Frequency is given 3, 4, 2, and 1. Okay, the frequency is given 3, 4, 2, and 1. 3, 4, 2, and 1. So we have to find the MD about median. So we have to first find the cumulative frequency. 3 and 4 is 7, 7 and 2 is 9, and 1, 10. So total is 10. So here that means the observation, it will be n by 2, that is 10 by 2, that is fifth observation. Fifth observation means it should be between here, 3 and 7. 5 will fall between here. So that means the median class is this one, 4 to 6. So we can write the median is equal to 4 plus 5 minus 3. This 5 minus 3 divided by 7 minus 3. 7 minus 3 multiplied by the class width. Class width is 2. So you can get it is equal to 4 plus, you can just work it out, 4 plus 5 minus 3 is 2. 7 minus 3 is 4 into 2. So it is exactly 1. 2 2s are 4. So it is 5. Median is 5, exactly 5. So we are getting median equal to 5. If we get the median equal to 5, I'm just writing median equal to 5 here, and I'm rubbing this portion because I need to draw one more column here. Now I will draw the midpoint. Okay, so 2 to 4, midpoint, MP. 2 to 4 is 3, 4 to 6 is 5, 6 to 8 means it is 7, midpoint, 8 to 10 is 9. The median is also known to us, 5. So the deviation, D is equal to how much? Midpoint is 3, median is 5. So the deviation is 2. Midpoint is 5, median is 5, deviation 0. Midpoint is 7, median 5. So it is 2. And 9 is the midpoint, median is 5. So it is 2. So we have got the deviations also. Now we multiply the deviation with the frequency because frequency is given. 3 into 2. Okay, so it is 6. So FD, 6. 4 into 0, 0. 2 into 2, 4. 1 into 2, 2. So I'm getting 6 and 4 is 10 and 2 is 12. So now we find out MD about median. So the mean deviation is coming to MD about median is coming to total 12 divided by, we are getting the total number of observations. Just a moment. 6 and 4, I'll just work it out and check. Any mistakes? 3 deviation, we have got 2, 2 3s are 6, 4 0s are 0, 2 2s are 4, and 2 1s are 2. So it is 12. Mean deviation is 12, and you can see that we have to find out mean deviation about median. So median we have got 5, and mean deviation is 12 divided by 10. Should come to 1.2. Okay. So this is how we are calculating mean deviation about the median. Okay. Just check. Here we have frequency 342. Deviation is 2. Deviation is 5. And just a moment. No. We have got the frequencies here. Deviation from 5. This is the midpoint. Midpoint is here. 9 and 5. Yeah, this is 4 actually. This will be 4. This will be 4. Because midpoint is, median is 5 and midpoint is 9. 9 minus 5 is 4. 4 into 1 will be 4. So this is 4. So 6 and 4 is 10 and 4, 14. Yeah. 14 by 10, so it is 1.48. 1.4. Okay. So we got the midpoint first. Midpoint is obtained. Of course, the median we have already got. So median value and the midpoint value we subtract, we get the deviation and multiply each of the deviation by the frequency. We get sigma FD, that is 14 in this case. 14 divided by the total frequency is 10. So 14 divided by 10, you are getting 1.4. 1.4 is the answer. The last one, these are a very important question, extra question which I have taken. Find the MD about AM. So we have to find MD about AM from the table. So the figures are given. You can just try it out yourself. You can take a screenshot of this. I will also upload it in the portal. Now we'll go into MCQ set A. Which of the following statement is correct? Two distributions may have identical measures of central tendency and dispersion. Yeah, which is correct? Two distributions may have identical measures of central tendency and dispersion. Yes, it is correct. Two distributions may have identical measures of central tendency but different measures of dispersion. That is also possible. Same AM, but different dispersion is possible. Third alternative is two distributions may have different measures of central tendency but identical measures of dispersion. That is also possible. Different AM but same, say the same deviation, that is possible. So all the statements are correct basically. So option D is right answer. Now let us look at the next one. Dispersion means or dispersion measures what? It is scatteredness. So option 1 is the right answer. You can see we were discussing many times that dispersion means the deviation, the scatteredness, how the observations are spread out. And spread out from where? Spread out from the mean or the median. Okay. Lastly, when it comes to comparing two or more distributions, which one do we consider? So we don't consider absolute, we consider the relative measures. So answer is B, relative measures. Last one, which one is easier to compute? Number 4, relative measures or absolute measures, both A and B, or is it range? Now, easier to compute, definitely range. Range is the easiest. So range will be the answer here. Which one is an absolute measure of dispersion, range or mean deviation? Is it range or mean deviation, or is it SD or all these measures? Absolute measure, if you see, range is also absolute measure. Mean deviation is also absolute measure. The relative measures basically is coefficient of range and coefficient of mean deviation. So here all the three which you see, range, mean deviation and standard deviation, are right answers. So obviously option D will be right, all these measures. Last question in this slide is what is the range of 15, 12, 10, 9, 17, 20? So here you can see the highest is 20 and the lowest is 9. So options I think are given. So option is D, the range is 11. Next question, set B. What is the coefficient of range of the following 8 workers? So coefficient of range. So it is given, you know, the coefficient of range is basically the range divided by the addition of the highest and the lowest value. So here you can see that the range is how much? Just let's calculate quickly. At least one problem from this, if you get in the exam, from this type of questions, if you get one problem from the range, at least you are assured of full marks. No, I'm sure everyone will get it right. Coefficient of range. So the highest you can see is 90. So the range is equal to 90 minus the lowest one. So the lowest you can see is 60. So we get the formula, therefore, is the range is 30. So 30 divided by 90 plus 60 into 100. That means 30 divided by 150 into 100. Okay, so it comes to 20. Next one, again, that same type of problem. This is important. If Rx and Ry denote the ranges of X and Y, and the formula is given, what will be the relation between X and Y? This is important question. I'm solving it. So it is given 3x plus 2y, 3x plus 2y plus 10 equal to 0. So from here we can write, we will take y in one side. So we can write 2y is equal to minus 3x minus 10. Or y can be written as minus 3 by 2x minus 3 by 2x minus 5, because 10 by 2 becomes 5. So it is now of the form a equal to a plus bx. So we can write that the range, the relation is between Rx and Ry. So we can write range of y will be equal to b, mod b, into range of x. In other words, Ry is equal to b is 3 by 2. So 3 by 2 into the range of x. Please note, minus 3 by 2 is given, but we are taking the modulus, absolute value. So it is 3 by 2. So you can see the relation becomes, the relation if you see is ultimately becoming Ry is equal to 3Rx by 2. That means if I just put 2 here, I am getting 2 into Ry equal to 3 into Rx. That is twice of Ry, 2 into Ry equal to 3 into Rx. So twice of the range of y is equal to 3 into the range of x. So 2ry equal to 3rx. So you can see in the options given, answer C is the right one. Acha, if the range of x is 2, what will be the range of minus 3x plus 50? Very easy. It will be just 2 multiplied by minus 3. Answer is minus 6. Option C is right answer. Option C, please note, is the right answer. C is the right answer. Yes. Yeah, many of you are answering. Great. Priyanka, Bhumika, Muhammad Ali, Jyoti, Mayur. Great, great, great. Please carry on in this way so that you get complete confidence on the chapter. Okay. So minus 6. The last one, if the relation between x and y is 5y minus 3x equal to 10, then the mean deviation of y about mean is how much? So once again, similar type of problem, but very, very important. You can see these problems are repeatedly coming. So 5y minus 3x equal to 10. So I can write 5y equal to 3x plus 10. That is y equal to 3 by 5 into x plus 10 by 5. Okay, now we know that the mean deviation for x is 12. Okay, so therefore the mean deviation of y med is equal to mod. So mod means 3 by 5 into 12. 3 by 5 into 12 should give us how much? Just let us try it out. 3 by 5 into 12 means 0.6. So it should give us around 7.2. 3 by 5 is 0.6. 0.6 into 12. 7.2 is the answer. I'm getting 7.2. Y mean deviation is 7.2. Option A, therefore, in this question. If two variables x and y are related, this is a lovely question, very, very important question for the exam. Lovely question from the Board of Studies. If two variables x and y are related like this, and the mean and the mean deviation of x are 1 and 0.3, then what will be the coefficient of mean deviation of y about its mean? Please see this question carefully. Lovely question has come from the Board of Studies. It's a combined question. So we just try and write the equation first. 2x plus 3y minus 7 equal to 0. Okay, just follow step by step. So I can write 3y is equal to 2x comes here minus 2x plus 7. So I can write y is equal to minus 2 by 3x plus 7 by 3. Now it is given that the mean and mean deviation about mean are 1 and 0.3. Be very careful here. It is given that the mean and mean deviation, so x value, mean and mean deviation, we have got the mean and mean deviation of x are 1 and 0.3. So if the value of the mean of x is 1, then the value of the mean of y will be how much? It will be minus 2 by 3 into 1. Instead of x, we'll put 1 plus 7 by 3. So that will give us minus 2 by 3 plus 7 by 3. That means 7 minus 2 is 5 by 3. So this is the mean of y. Y-M-E. This is y mean. Now the question is, we have to find out the mean deviation of y. X mean deviation is 0.3. So YMEV, mean deviation of y will be 0.3 into modulus b. Modulus b is 2 by 3 into 2 by 3. So it is 3 by 10 into 2 by 3. So 3 cancels, 2 by equal to 1 by 5. 1 by 5. So y mean deviation is 1 by 5. So therefore, the question asks you coefficient of mean deviation of y. What is the coefficient of mean deviation of y? That is the question. Now the coefficient of mean deviation of y will be how much? Coefficient of mean deviation is equal to coefficient of mean deviation is equal to MD by mean. MD by mean into 100. MD by mean into 100 is the formula. Now as per what we have done, y mean deviation is 1 by 5. So I am writing 1 by 5. And we are getting this mean of y is 5 by 3. So this divided by 5 by 3 into 100. So it is 1 by 5 into 3 by 5 into 100. Please note 1 by 5 into 3 by 5 into 100. That is 3 by 25 into 100. So I'm writing it here 3 by 25 into 100. 25 4s are 100, 4 3s are 12. I'm getting the final answer 12. Y mean deviation, that is coefficient of mean deviation of y, comes to 12. So the option is option B, therefore is the right answer. So we have solved it out. Ninth one is B. Yes, thank you. Yeah, so we have solved it out, mean, and then we have got the mean deviation of y, that is 1 by 5, which we got, and then the formula for mean deviation coefficient is MD, that is mean deviation divided by mean into 100. That gives us 12. Fine, so that brings us to the end of the session, and I hope you have followed it. We discussed about dispersion, and we then took over the discussion of range. Very easy to calculate. We did it both for ungrouped and grouped, and thereafter we went into mean deviation, and we have calculated mean deviation from the mean as well as mean deviation from the median. So next day we will take up the next chapter, the next portion of this chapter, which is going to be QD, that is quartile deviation and standard deviation, which are linked. Both of them are actually, you will find they are absolute measures, and from there we will also find out the quartile deviation, coefficient of quartile deviation, which will be a relative measure. So I hope you have followed it, understood, cleared your doubts, and please practice, and we'll meet again on 23rd to take over the next portion of this particular chapter. Thanks, and see you soon.